Okay. Hey, today we're going to be talking about angle measures in radian, or angles in radians. A couple things to kind of draw to what you already know. Okay, before we even start, page 247 of your student journal, you can maybe write it on the, you have a little room on the bottom you can take some notes on if you need to. But, in fact, I'll write it down there right now. I want you to write the formula for circumference of a circle, please. Okay, circumference is equal to 2 pi radius. Some of you would say pi d, but a diameter is 2 radii, so we could call it 2 pi r. Okay, now 2 pi r, now Mr. Vogel would say, like he uses like little things to remember, like 2 pi r better than 1. C d pi, E d pi, that kind of stuff. Okay, hey, 2 pi r, that's our formula. Now, if I tell you the radius of a circle, and when we're dealing with trig, we call it the unit circle, which means the radius is 1 unit long. That means this r gets replaced with 1. Okay, so the circumference then is 2 pi units. Oops, not 2 equals 2, but circumference is equal to 2 pi. Okay? 2 pi times 1 or just 2 pi. Good there? Walsh? Pay attention. Okay? So, when I'm dealing with radians, which is what you're doing today, what you're actually doing is you're trying to figure out how many radiuses will fit around the outer edge of a circle. So if I have a circle, that one's not amazing, but okay, and I have a radius, I'm trying to figure out how many of these radii would fit around the outer edge. That is what you're doing when you're measuring in radians. You're measuring based upon the radius. Yeah. Okay, and in a unit circle, the radius is 1. All right, so you're saying, hey, how many radii will fit around there? And we've just figured out that many will fit around there. How many is that many? 2 pi is about how many? 6.2 times pi is 6.2. 6.283, blah. Okay, so, all right, 6.28. So about 6.28 radii will fit around the outer edge. Now the cool thing about circles is all circles are similar. So when you change a linear measurement, it changes proportionally. So since circumference is a linear measurement, meaning it's not area, okay, and radius is a linear measurement, when I change how big the circle is, the number of radii change proportionally. That will fit around the outer edge. So in this circle where there's radius is 1, in this circle where the radius is 2, well, 6.28 radii fit around this one. The same thing would happen on this one. It'd be 6.28. That's why we can measure in radians. So when we're talking about radians, we're saying how much of the radius is it from one point to another. Okay? So let's go up here real quick. And what we have been used to is measuring in degrees. Okay? And what we've just shown down here is that if we always start, by the way, from here. This is called your terminal, or excuse me, your initial side. Okay, you start here. I'm going to draw a little arrow right here. Anyone ever seen like a radar map where that little thing sweeps around and you see beeps? Like beep. Okay, that's what you're dealing with here. Okay, this little arm will sweep around. It starts here, this is its initial position, and it moves around the center of the circle. It just keeps swinging around, okay, until it gets back to the start. And it just keeps going like that. Very boring. Okay, you just keep going around in a circle like that. it's called periodic data. It's data that won't, it looks the same. If you were to graph it, the graph looks very much the same, no matter what chunk you, piece of the graph you look at. Okay, so if I start here at 0 degrees and I sweep around my circle to there, I've traveled 180 degrees. Everyone with me? And I keep sweeping around. I've now done one revolution, which is 360 degrees. Okay, now we know 360 is how many radians? 6.28, which we don't call 6.28 because that's rounded, so we leave it in this form, which is 2 pi. That is 2 pi radians, which means a half of a revolution is 1 pi, and that's why they have that little pi symbol right there. 1 pi radians, which, if you know a full revolution is 2 pi, half is 1 pi, let's cut it in half again. What's 90? Half of pi, which we call pi over 2. And then let's cut that in half again. 45 is? Half of a half is 1/4, so pi over 4. What is 0 then? Yeah, it's 0 pi, which 0 times anything is 0, or here or there. Okay, 0 pi. Okay, we get 0 pi, 1/4 pi, 2 quarters. By the way, if you're dealing with money, 2 quarters is how much? 50 cents, which is what part of a dollar? 1/2 pi. Okay, and 1/4, 2 quarters, 3 quarters. 3 quarters pi, or 3 pi over 4. What's 4 quarters? 1 pi. What's this one and this one and this one? Go ahead and finish that up. Okay, compare with your neighbor there. So this is 4 pi, 5 pi over 4. 6 pi over 4. What is 6 pi over 4? Also 3 pi over 2, which we would want to use the simplified version. This is 7 pi over 4, and this is 8 pi over 4, or 2 pi. Right? 8 divided by 4 is 2. So you guys remember yesterday when I said, hey, you're going to have to memorize all this stuff. Well, you have to memorize all of these. However, how difficult was it to figure them out once you knew 360 is 2 pi? It's pretty easy, right? You just follow the patterns. You know the same thing over here. By the way, notice these angles are your special angles. They're angles of 45 degrees. Every 45, 45, 45, 90 is a special right triangle. What we'll eventually do is we'll make a little triangle here, and you're like, hey, that's a 45, 45, 90. And this length is actually this coordinate. And this length is that coordinate. And you'll memorize those coordinates. And those coordinates, by the way, just to tie it to what you learned yesterday, those coordinates happen to be those same measurements you were learning yesterday of these lengths. Okay? We'll get to that a little later down the road. Okay? Hey, right here, we know what 2 pi is. Remember, your angle starts right here. This is 2 pi is 360 degrees. We know 0 degrees is 0 radians. So if we want to think of, so let's put radians and degrees here. 0 radians is equal to 0 degrees. 2 pi radians is equal to 360 degrees. Using that information and knowing that 180 degrees is how many radians? 1 pi. That ratio right there is one that you'll use for conversions, by the way. Okay? Knowing all of that, I want you to fill in what these are. Okay? Work together. All right. Hey guys, you're going to see me always go back, rather than going to 2 pi equals 360, I'm going to be always going to pi is 180. Okay, because it's easier than, the first thing I do here, if 2 pi is 360, the first thing I'd do is I would reduce it to pi over 180. Okay? So when I know that, if I know that 180 degrees is pi radians, how many 30s are in 180? How many? 6. So this is pi over 6. You divide pi by 6. Okay? And if 30 is pi over 6, 60 is 2 pi over 6, which we know as 1 pi over 3. And that's the angle, or excuse me, that is the measurement you would want to use there. That means from here to there, it's when a 60-degree revolution is pi over 3 radians. That means 1/3 pi is this distance. Okay? From here to here, or excuse me, from here to there, if this is pi over 6, pi over 3, this is, we skipped one, right? Because 90, that's 1 pi over 6, that's 2 pi over 6, this is 3 pi over 6, which we already know is pi over 2. This is 4 pi over 6, which is 2 pi over 3. And that's the measurement we would want to use. We want to use the simplified. So 4 pi over 6, this is 5 pi over 6. So some of you will just get in the habit of writing the pi's over 3. You'll say, okay, I know 30 is a pi over 6. This one's a pi over 3. 60, that's 1 pi over 3. The next 60 is 2 pi over 3. The next 60, so 120 plus 60 is 3 pi over 3, which is pi over 180. Okay, but if you just count by 6, you can do it also. 1, 6, 2, 6, 3, 6, 4, 6, 5, 6, 6, 6. This one is 7, 6. Okay. Okay. 8, 6. 8 pi over 6, or 4 pi over 3. Okay. Notice we can't break this one. Well, we won't go there. 8, 6, 9, 6, 10, 6, which is 5 pi over 3. And the last one, good, 11 pi over 6. Okay, how many of you think you can do that? You will have to be, we will start doing some of these as warm-ups, and I will guarantee on one of your quizzes, you will just be given a unit circle, which is what this is, and you will have to fill in every part of it. Without a note card, without a calculator, because you won't need it. Okay? All right, it will be fun. Okay, so from that point, what we're going to do is we're going to focus on this thing they told you at the very beginning. Bless you. Pi over 180. Okay? Pi over 180 is a ratio that we're going to use. Very good? Everyone knows where we get that, right? Okay. Questions so far? This is awesome. Okay. Moving on. Exploration number 2. Woo-hoo-hoo! Score. All right. Why don't you take a look at exploration number 2. So, I heard some good discussion. There are a couple ways to do this. I would like to do it kind of the intuitive way before I show you the mathematical way. Now look, we know that if we start here and rotate around our circle, you grab our cool colors here, okay, and we rotate around the circle halfway, we have traveled how many degrees? 180. And in those 180 degrees, how many radians did I travel? I have not traveled 1 radian, no. I have traveled 1 pi. Pi is equal to 180, right?
That was what I was going to say, but then you cut me off, so I said 1, and then I was going to say pi.
Oh, good thinking. Okay, so we have 180 degrees is equal to pi. That means if I have 2 pi over 9. That looks really messy. Let me just take half of that and think of it as pi over 9. What is 1/9 of 180? It's 20 degrees, which means 2/9 of pi is 40. 4/9 is 80. 5/9 100. Every ninth is how many degrees? Every ninth is 20 degrees. So 7/9 is 140. Now, if you would have got 200 right here, we would have had major issues, right? Because that's 180. We're like traveling around. We're like, okay, 200, 180, whoops, wrong. I'm going to tell you, like when I was coming back from Disneyland a year and a half ago, we're traveling on I-5 out of Los Angeles. I'm just like talking with my family, cruising around. And I always look at the exit signs, especially going through California, because it's like you like going down to Disneyland from Oregon, if you've ever driven that. You leave Oregon and all of a sudden it's like exit 798 and you've got to get to exit 100 or something. I'm like, you got to be kidding, dude. I've got to that's a long, every one of those is a mile. So we're talking like 600 miles, 700 miles. So I'm just looking at the exits. I'm like, all right, I know to leave California, I got to get to exit 790, whatever. We're at exit, I don't know. Yeah, whatever. It's like exit 12, 13, 14, 17, 36. What? Whoa, what? I had like accidentally switched off of I-5 onto 99. And so I'm asking my wife, I'm like, did you see an exit? Like we just like it just kind of switches. I'm sure it gave advanced warning. I wasn't paying attention, but it switched and I was really messed up. I was like, hold on, that numerically does not make sense. Okay? Well, that's what we did right away is we went to the maps and we figured out we were on like a parallel highway. We could look over and see everyone on the other one. We're like, hey, what's up? We're over here. Okay? So logically speaking, when you're doing these, if you start following along, you're like 20, 40, 80, 100, 200, 180. Whoa, we got some problems. Okay? Every ninth should be 20 degrees. That means we get to 140, 180. The next one should be bigger than 180 because you've added more ninths. Okay, this is 9 ninths. This is 11 ninths, or 11 times 20, which is 220. 13 times 20, 260. 14 times 20, and 320. And the last one would be, and that would be 18, right? 360. Okay? Guys, the other way you could have done this is the mathematical way. Mathematically, we know that pi over 180 is equal to radians over what? Degrees. That is the proportion you want to use. And you'll see me kind of switch it around. Sometimes I'll write it like this. Sometimes I'll write it like this. It annoys some of the type A people out there. Okay? It doesn't matter. Okay? They're both the same thing. Okay? So, no matter what, the first thing, if I want to find out how many degrees, for instance, if I'm, say, this is going to be kind of an ugly one, but if I have 2 pi over 9 radians, how do I know that's a radian measure? Good, because it has like pi. Yeah, that's why. Okay? Now, you could have radians that, like if we actually did, everyone on your calculator do 2 pi divided by 9. It's about 0.6 what? Okay. So that is the decimal equivalent to 2 pi over 9, approximately. Okay? That's why we leave it as 2 pi over 9. So technically you could have radians. You could have radians that are, listen please, so you can make the connections that are going to help you. Okay? You could have radian measures that are not that do not have pi in them. But note that, remember, a radian says how many of these you've moved, right? Okay? And so, like this length right here, can you ever, as you're kind of stretching it around here, okay, this length, we're going to 0.69. What we're going to find out when we start drawing these little triangles in here is we're going to figure out this distance and these different coordinates. You're going to go like, you're going to figure out that, well, I don't really want to give it away, but you're going to figure out some different relationships in here where certain values can't get over a certain amount. Okay? So stay with it, but when you're dealing in radians, if you see a goofy looking decimal, what can this decimal never get bigger than? Come on. What's the biggest amount of radians here? In one revolution, what's the greatest number of radians? 2 pi. So what's the biggest number that decimal can go to? 6.28. That's in one revolution, right? 2 pi equals 6.28. So if you're trying to figure out if you're in radians or degrees, if you're a real small number with decimals, there's a chance you're in radians. They would usually label that. If you see like 2 pi over 9, something with pi in it, you're in radians. Okay? So if I want to convert 2 pi over 9 to degrees, I'd have to come over to my proportion here, and where it says radians, I'm going to put 2 pi divided by 9. And where it says degrees, I'm going to put x. Okay? And so let me erase this down here. And we could actually calculate that mathematically. We just cross multiply. That's pi times x, which I know looks weird, equals, yeah, that's really kind of ugly. See how we get another fraction here? So anytime you put a fraction like this up here, this little 9, that can actually just drop down to the denominator. That just makes 2 pi over 9x, which means we have a 9 out here now when we cross multiply. And that gives us 360 pi. How do I get x by itself? Divide by 9 pi. It cancels here. When I divide by 9 pi here, I get 40. That's how many degrees. That's algebraically how you can solve. Okay. Here's what I want you to do. I want you to answer questions 3 and 4 with your groupies on that page, please. Around, here's what I saw. I saw most of you with number 3. I saw a lot of you had something like this. Something to this extent. Like use this. And then you put that, okay? Something like that. How many had something like that? All right. Then I saw number 4 just like that. You guys had that. Like not much done. Okay, you just told yourself how to do it. I mean, you told yourself what to do. Don't let the wordiness of it get in the way. Do the math. This, by the way, just means it's kept going around, right? This says 30 radians. That, like, 2 or 6.28 radians is one revolution. That means how many 6.28s are in 30? About 5. That means this rotates about 5 times. There's 1, there's 2, 3, 4, 5, and a little more. Okay? That's what's happening there. 30 radians. 6 radians is approximately 1 revolution. So when you go 30 times, you're doing about 5 revolutions or so. Okay? But you still just plug it in. There's 30 radians. Now remember, up here we said, hey, maybe it has to be a small number, or it has to be in terms of pi, or they have to label it radians. That means it's radians and not degrees. approximately, yikes, dude, approximately 1,719 degrees. Okay, how many times greater is 30 radians than 30 degrees? Well, you'd have to figure out how many 30s go into that, right? 1719 degrees divided by 30 degrees is approximately approximately 57.3 times greater than 30 degrees. Okay, that's a big deal. You're all at 30 degrees, 30 radians, same thing. No, not so much. Okay? All right. That's a lot we've just covered. How many of you that was all brand new? Yeah, what did you learn today? Pretty radical stuff. Okay? I want you to tell your neighbor something you learned, please.
Not really radical, more revolutionary.
It is revolutionary. Woo! All right. Hey, turn the page, please. Page 249er. Okay, on page 249 of your student journal, you have a bunch of definitions up here. When you slide it down, we've talked about some of those things. Okay, we've talked about initial side. That's this side where it starts on the x-axis. Terminal side is where it ends. Okay, so as you rotate an angle around, where you stop it, that's called the terminal. Terminal means end. Okay? Standard position is when its vertex is at the origin and its initial side lies on the positive x-axis. So this angle would be considered in standard position because it started here. It extends from the origin. So this angle is in standard position. Okay, so as you're looking at, let's switch this real quick. I just want to go to, we'll come back to that, but go to page 251. It says, draw an angle with the Gibbon measure in standard position. That means start here and rotate counterclockwise till you get to 260 degrees. So everyone right now, do number 1. You can approximate. You don't have to be exact. Approximately where would that angle terminate? Okay, note you're at 0 degrees here, you're at 90 here, you're at 180 here, you're at 270 here. 260 is right before 270, so you'd rotate around till right before that, 260 degrees. That's a big degree symbol. Okay? Any questions there? All right. Want to go back to the previous page, page 250. Note up here, this says degrees to radians and radians to degrees. Now, why do they switch them around? And just to confusion, it doesn't matter which one you use, right? But when you go up here to the next part, you guys back there would be done talking. Let's focus. Okay, degree and radian measures of special angles. Everything we covered today is listed right here. The stuff we did in the exploration. Kind of gives some explanation there, but you may want to summarize it in your own writing. Okay? And then down here, they start talking about geometry stuff. Remember last year in geometry, at the end of the year, you started dealing with arc length, area of sectors, all that stuff in circles. Okay? A sector is like a piece of pizza. Okay, it's a shaded piece, including the crust. If you cut off the crust, sorry, that's a segment that you cut off. But this whole thing's a sector. The arc length is equal to, your sector is equal to the radius times theta. Okay, the radius times whatever your angle theta is. That's your arc length. Okay, the area of the sector is 1/2 the radius squared times theta. And we'll go through some of this a little later on, but that's just some information to have there. What I'd like you to do tonight as your assignment is I want you to practice some of the stuff we've done. So I want you to complete number 2 on page 251 and number 7, 9, 8, and 10. Okay? Those should not take too long. So the other thing you must do tonight is you have to look up, and I never make you look up anything, But I want you to look up what a coterminal angle is. Okay, what is a coterminal? Add the word angle here. What are coterminal angles? You should know that, and if you really think you get it, then try to answer a couple of these questions. It's really not a tough concept. Okay, it says find one positive, one negative, but look that up. All right, very good.